continuing with this question, I included the remaining parts B through D, as well as the frequency distribution and the relative frequency distribution that I got in StatCrunch. I basically just entered these values myself into the third column. As a reminder, for part A, when we wanted the probability for ages 30 to 39, I simply took these two probabilities and I added them together. And after rounding to 3 decimal places, I got this value. Let's look at part B. Part B is asking for all the probabilities that don't involve these two columns. So basically everything outside of 30 to 39. One way to do this would be to add up the first 3, skip over these 2, and then add up the last 2 probabilities. That would be the probability for everything except this. However, there is a faster way to do part B. If you want the probability of being, not 30 to 39, we can do 1 minus the probability of 30 to 39. It should be that this and this add up to 1 because that is 100% of the data. So to get this value, you can take 1 and subtract this answer. So I'll write that out. This should be 1 minus 0.631. You can do that right in a calculator, but that is 0.369. So that is going to be the answer for part B. So again, 2 ways to do that. You could add up this, this, and this. You're skipping over these 2 because we don't want to include this. That's what this not means. And then you would add the final 2 together, and you would get this value here. But a faster way is, since this and this should add up to 100% or 1, you can just subtract off the previous answer to get your value. I think we can use a similar idea in part C. So let's check that one out. For part C, okay, we want the probability of being less than 45. So I'll put probability and then less than 45. So that means if you're less than 45, okay, you're not including this category here, but you're including everything that is less than it. So one way to do that would be to add up the probabilities from here up to here. So you would just not include this last one. But a faster way would be, well, if you took 1 and subtracted this number, that would be the same thing as adding up the previous values. So that's what I'm going to do. I'm going to solve this by taking 1 and subtracting the probability of being 45 to 54. So that's going to be 1 minus, I'll actually list out all the decimals this time, but that's going to be 0.1568203. I'll do this in my calculator and round my answer to 3 decimal places. 1 minus 0.015682033. When I round to 3 decimal places, I get 0.984. And that makes sense. If you look at this category, there's a very small likelihood. So if we mean the rest of the data, I would expect it to be a very large probability, and it is. It's really close to 1. Okay, finally, let's look at part D. Okay, this one says determine the probability of being at least 40. And then we're asked if this result is going to be unusual. Okay, being at least 40 means you're 40 and above. So we're not including these, but we're talking about the probabilities from these 2 categories. So for D, the probability of being at least 40, okay, that's going to be the probability of being 40 to 44, and we're going to add on the probability of 45 to 54. So what's happening here is, since I want the probabilities from these two categories, I can simply add these two values together. I'm going to run out of room, so I'm just going to do this in my calculator. I'm going to add up these two probabilities, and I'm going to round to 3 decimal places. So that's 0.051372178 and 0.015682033. When I round this to 3 decimal places, I get 0.067. Oops, that was supposed to be a 7. The big takeaway from the remaining parts of this question are, you can just add up categories that match up with what the question is asking for. Like that's what I did in part D. I just added everything from 40 to 54. Or sometimes you can subtract values from 1 if that is going to be faster. There's a couple more parts for D. It says to interpret this result. So this was the probability of a randomly selected person being 40 to 54 years of age. Well, what would that mean about if you had 1,000 multiple births for women in this category? Well, it doesn't tell us anything exactly. It tells us something, that's roughly or about. So what you'd like to do is you want to choose option A, and you want to know, well, about how many is this going to be? To get the value that goes here, since we're talking about 1,000 events, you would take 1,000 and you would multiply by the probability in this part of the question, which is 0.067. You could do this on a calculator if you'd like to, but I know multiplying by 1,000 is going to move the decimal place 3 places. I would expect about 67 if that's what the probability for part D was. There is one final part in part D, and it asks that, is this probability of at least 40 unusual? Now, the answer we got was 0.067. And if you like to think about that more as a percent, if you multiply by 100, that's roughly 6.7%. There's a definition for unusual, and the cutoff point is 5%, less than 5%, or 0.05. If something is greater than this amount, we would not say that it's unusual. So this actually is not unusual, and that's because this value is greater than 5%, or the probability is greater than 0.05. So I just want to make sure that I select the correct option that reflects this. Let's see. The answer would be no, and that's because this probability was greater than 0.05. Now, if you wanted to look at something that was unusual, if you consider just the probability for 45 to 54, now that probability, if we round to 3 decimal places, and here I'm just directly looking at this category, I would round and get 0.016. Or, if you'd like, 1.6%. Now, that is definitely unusual. I mean, the probability is less than 0.05, or if you'd like, the percent is less than 5%. So this is what we mean by an unusual event. It's defined to be less than 5%.